Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2016. So let's get started. First problem, what is the value of this when a equals 1/2? So what we just have to do is put 1/2 into this equation, right? And so 2a to the minus 1 power equals 2 times 2, and then that plus a inverse is 2. So 2 over 2 all over 1/2, right? 1/2. And so this over 1/2, this much equals just multiplying by 2, right? So it's 2 times 2, which is 4, plus 1, equals 2 times 5 equals 10, right? So the answer is D. Number 2, if n heart m equals n cubed m squared, what is this? So same thing, we can just plug in this, right? So 2 cubed 4 squared over 4 cubed 2 squared, and so these will cancel and these will cancel. So this is 2 over 4, this is 1 over 2, so the answer is B. Number 3, let x equal negative 2016. What is the value of this? Same thing, we can just plug in 2016 into each of these x values, right? But then we will need to kind of keep track of what is what, right? So first we have this, that is the absolute value of x. That will be 2016, and 2016 minus negative 2016, right? So that's 2016 times 2, which is 4032, right? So this much is 4032, and since we have the absolute value of that, that is also 4032, right? And this time we subtract it by the absolute value of x, which is the absolute value of negative 2016, which is 2016, right? And so this much is 4032 minus 2016, which is basically just 2016, right? And so now we have the absolute value of that, which is basically just 2016, and so this is 2016. And now what we have to do is 2016 minus x, right? And so that's 2016 minus negative 2016 equals 2016 plus 2016, right? So this equals 4032. The answer is D. Number 4, Zoe read 15 books one at a time. The first book took her 1 day to read, the second book took her 2 days to read, the third book took her 3 days to read, and so on, with each book taking her 1 more day to read than the previous book. Zoe finished the first book on Monday and the second on a Wednesday. On what day of the week did she finish her 15th book? Okay, so since Zoe finished the first book on Monday, that means Zoe started on Sunday, right? And on what day of the week did she finish her 15th book? And so the number of days taken to read all 15 books is 1 plus 2 plus 3 plus all the way to 15, right? And this is 15 times 16 all over 2, which equals 120, right? And 120, this equals, if we divide by 7, then this is 7 times, and then we have 17. 7 times 17 plus 1, right? And so this plus 1 is what is important, because it means Zoe took 17 days and 1 week and 1 day more. And what day of the week did she finish her 15th book? And so since she started it on Sunday, then she would have taken 1 more day, right? So Sunday plus 1 equals Monday. So the answer is B. Number 5, the mean age of Amanda's 4 cousins is 8 and their median age is 5. What is the sum of the ages of Amanda's youngest and oldest cousins? Okay, so let's say that the ages of Amanda's cousins are A, B, C, and D, and since their mean is 8, A plus B plus C plus D equals 4 times 8, 32. And the median age is 5, but since this is an even amount of ages, right? So the median is the average of the middle two. So B plus C over 2 equals 5, and so that means B plus C equals 10. And so if we subtract these two, then we have A plus D equals 22, right? And what's the sum of the ages of Amanda's youngest and oldest cousins? That is actually a plus d, so we have 22. It's our answer. It's D. Problem number 6. Laura added two 3-digit positive integers. All 6 digits in these numbers are different, and Laura's sum is a 3-digit number s. What is the smallest possible value for the sum of the digits of s, right? And so since we have two 3-digit positive integers like this, and all six digits are different, but we need to get the smallest value for the sum of the digits, right? That means we need to make as many zeros as possible, right? And so to get that, we need the sum of those two to be 100, and that should be the smallest, right? And first of all, for this to be the smallest, there's only 1 and 2, right? And for the sum of these to be to be 100, we have, what can there be? We can have 7 and 3, and so 7 and 3 and 5 and 4. That will work, because if you add 57 plus 43, that is 100, right? And so the sum of all this is 400. So the smallest possible value for the sum is 4 plus 0 plus 0, which is 4. It's B. Number 7, the ratio of the measures of two acute angles is 5:4, and the complement of one of these two angles is twice as large as the complement of the other. What is the sum of the degree measures of the two angles? Okay, so since the ratio is 5:4, then those two angles would be 5a and 4a, right? And those complements would be 90 minus 5a and 90 minus 4a. Let's say we're dealing with degrees here because it's the degree measures, right? And the complement of one is twice as large as the other. And since 90 plus 4a is larger than 90 plus 5a, 90 plus 4a would equal 2 times 90 minus 5a, right? So if 90 were to go over there, then that means 90 equals 10a minus 4a, and that is 6a, right? 90 equals 6a, and so let's divide by 6 on both sides. A equals 15, right? What is the sum of the degree measures? And so we need to do 5a plus 4a. This equals 9a, right? And so 9a equals 9 times 15, which equals 5 and 135. So the answer is 135. It's C. Number 8. What is the tens digit of 2015 to the 2016th power minus 2017? Right. So first of all, 2015 to the 2016th power, that is since the ones digit is 5 and it is to a very high power, that means the last two digits, last two digits of 2015 to the 2016th power will always be 25, right? Because because if you just look at the multiples of 5, right? So we have 5, and then we have 5 squared 25, and then we have 125, 625, right? And so if x, so, and if the power is greater than 2, it always ends with 25, right? And so the last two digits of this will always end in 25, and we know that the last two digits are 17, right? And so we want the tens digit, so the last two digits are all that we need. So we have 25 for this number minus 17 for this number. And what do we have? This is 0, 8, right? So the tens digit is 0. It's A. Number 9. Number 9. All three vertices of triangle ABC are lying on the parabola defined by y equals x squared, with A at the origin and BC parallel to the x-axis. The area of the triangle is 64. What is the length of BC? Okay, so we have the parabola y equals x squared, like that, right? And we have A at the origin. So this is A, and BC is parallel to the x-axis. So if we draw a line like that, then this would be B, and this would be C, and those will be parallel to the x-axis. And so the area of the triangle is 64, and our triangle is right here, right? And so the area of this triangle is 64. What is the length of BC? And so let's say that the x value, this is A, right? And then so this length would be A, this will be A2, right? And since this is x squared, y equals x squared, that means the y value right here, this will be a squared, right? So this is a squared. That is a squared, right? And so the area of the triangle is 2a times a squared times 1/2, because it's a triangle. This is a cubed. This is 64. So a equals 4. So the length of BC equals 2a, which is 8. So the answer is C. Number 10. A thin piece of wood of uniform density in the shape of an equilateral triangle with side length 3 inches weighs 12 ounces. A second piece of the same type of wood with the same thickness, also in the shape of an equilateral triangle, has side length of 5 inches. Which of the following is closest to the weight in ounces of the second piece? Right, okay, so we have two pieces of wood. One is a triangle with length 3 inches, and one is a triangle with length 5 inches, right? And we need to compare the weights, right? But then since they have the same have the same thickness, then their weight will be proportional to their area, right? And so we need to find out the ratio of their area. And since they are both equilateral triangles, they are similar. So our length ratio is 3 to 5, and therefore our area ratio is squared, right? So 3 squared, which is 9, to 5 squared, which is 25. So this is our area ratio. And so the weight of the second piece will be 25 over 9 times the weight of the first piece. And the weight of the first piece weighs 12 ounces. So that's 12 ounces. And so if we calculate this, this will be 25 times 4 over 3, which is 100 over 3, which is 33.3 ounces. So the answer is D. Number 11. Carl decided to fence in his rectangular garden. He bought 20 fence posts, placed one on each of the 4 corners, and spaced out the rest evenly along the edges of the garden, leaving exactly 4 yards between neighboring posts. The longer side of his garden, including the corners, had twice as many posts as the shorter side, including the corners. What is the area in square yards of Carl's garden? Okay, so Carl had 20 fence posts, but then if you try and kind of like model this, right? Then when you count the number of posts on each side, you will count. Then you will see that all of these corners, they are counted twice, right? And so make life kind of easier. We will add 4 to the number of fence posts, and so that way we can so that way we can calculate the number of posts easier, right? And so if we add 4 to 20, then that gives us 24 posts, right? And then we have A posts and 2 A posts here, A posts and 2 A posts here, right? And so 6A equals 24, and so A equals 4, right? And so we have 4 posts and 8 posts, 4 posts and 8 posts, right? And if we do that, then that will look like 1, 2, 3, 4, and then this counts as one more. So 1, 2, 3, 4, 5, 6, 7, 8, and 4, and 2, 3, 4, 5, 6, 7, and this is 8. Right, and so what is the area in square yards of Carl's garden? And so we have 3 gaps, and on this side we have 7 gaps, right? And there are 4 yards between each neighboring posts. So this is 3 times 4, 12 yards, and this is 7 times 4, 28 yards, right? What we need to do is 28 times 12, right? And 28 times 12, this is 336. So the answer is B. Number 12. 2 different numbers are selected at random from 1, 2, 3, 4, 5 and multiplied together. What is the probability that the product is even? Right, okay, so for the product to be even, then this is just the probability of, then that is actually just 1 minus the probability of odd, right? Because it's either even or odd, and calculating the probability of it being an odd number is much easier, because for the probability for multiplications to be an odd number, that means all of the numbers have to be odd, right? And so we have 3 odd numbers and we have to choose 2 of them, right? So that's 3 choose 2. That's 3 ways to get odd numbers, right? So the probability of odd is 3, which is from 3 choose 2, from 2 different numbers being selected from 1, 2, 3, 4, 5, the whole thing, right? So 5 choose 2, and that's 10. 5 choose 2, which is 10. And so 1 minus probability of odd, 1 minus p odd equals 1 minus 3 over 10 equals 7 over 10 equals 0.7. So the answer is D. Number 13, at Megapolis Hospital 1 year, multiple birth statistics were as follows. Sets of twins, triplets, and quadruplets accounted for 1,000 of the babies born. There were 4 times as many sets of triplets as sets of quadruplets, and there were 3 times as many sets of twins as sets of triplets. How many of these 1,000 babies were in sets of quadruplets? Okay, so let's say that there are a set of twins, and B sets of 3, B sets of triplets, and C sets of quadruplets, right? And so there are 1,000 babies in total. So 2A plus 3B plus 4C equals 1,000. And there were 4 times as many sets of triplets as sets of quadruplets, right? And so that gives us that so triplets B equals 4 times quadruplets. And there were 3 times as many sets of twins as sets of triplets. So so twins, so A equals 3 times triplets, 3B, right? And so since A is 3B, this equals 12C, right? Because of this right here. And so if we put in B equals 4C and A equals 12C into here, then that will give us 2 times 12C, because that's A, plus 3 times 4C, because that's B, plus 4C equals 1,000. And so 24C plus 12C plus 4C equals 1,000. And 24 plus 12 plus 4, that gives us 36 plus 4, which is 40. So 40C equals 1,000. So C equals 25. So we have 25 sets of quadruplets, but it said how many of these 1,000 babies, not how many sets, right? And so we need to do 25 times 4, so this is 100 babies. So the answer is D. Number 14. How many squares whose sides are parallel to the axis and whose vertices have coordinates that are integers lie entirely within the region bounded by the line y equals pi x, the line y equals negative 0.1, and the line x equals 5.1? Okay, so let's try to do this in a coordinate grid. So let's let's get our grid here, and we will make an axis, and we will make x-axis, y-axis, like that, right? So first, our x-axis, it will be somewhere like that. That will be our x-axis, and our y-axis will be like that, right? Let's make it more accurate, like that, and this will be a little bit lower, right? And we need our line 0, minus 0,1, and 5,1, and 5.1. So first of all, y equals negative 0.1. That will be very slightly less than that will be very slightly less than y than the x-axis, right? And so that will be about right here. And our line x equals 5.1. That will be very slightly to the right of the line x equals 5, and so that will be our x equals 5.1. So this is 5.1. This is negative 0.1. And lastly, we have y equals pi x, and for this one, it needs to go through the origin, and negative 3.1 and negative 1 comma negative 3.14, right? And so it will go through here, and it will go through the origin, and it will go through 1 comma 3.14 and 2 comma 6.28 and everything like that. Yeah, and this seems like it's way too down, so let me move it up a bit. Move it to about here, right? Yeah, that should do the trick. And so let's move it down, and 5.1 is this 5.1, right? This line is 5.1, right? And what we need is we need the number of squares whose sides are parallel to the axes and whose vertices. Yeah, so squares like this, those kinds of squares are what we need. And so if we look, then we have those squares we can have the squares in the area that I'm outlining in green right now, and these are the area, and that's the area of squares that we can have, right? And the reason that we can have this point is because the drawings are a bit off, but this point is actually 3.14, and this green point is actually 3, so it is less, right? And the same goes for everything, but the and the points that are up here, they don't matter because they can't be a part of any square, right? And so first, let's see the number of 1 by 1 squares. That's just counting the number of squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, actually, it's better to just do 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 30. So we have 30 1 by 1 squares. And for our 2 by 2 squares, we have 1, 2 here, 2 plus, and then we have 3, 4, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15. We have 15 in total, right? 15 2 by 2s in total. And I was going in order from right down to left down like that. And our 3 by 3s, we have this 3 by 3, or this, or the one right below, 3, 4, and 5 3 by 3s. We have 5 3 by 3s and 4 by 4s. If we look, then we can't have any 4 by 4s. So we have to add these together. So it's 30 plus 15 plus 5, which equals 50. The answer is D. Number 15, all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 are written in a 3 by 3 array of squares, one number in each square, in such a way that if two numbers are consecutive, then they occupy squares that share an edge. The numbers in the four corners add up to 18. What is the number in the center? Okay, so first of all, let's draw this array of squares, right? And so this is our 3 by 3 array, 3 by 3 array, right? And we see that if we have odd numbers and even numbers, right? Then if we start with an odd here, if we start with an odd here, then this will have to be odd, then this will have to be even, this will have to be odd, this will have to be even, this will have to be odd, this will have to be even, this will have to be odd, and this will have to be even, and this will have to be odd, right? And if we start with this part, then this part would be odd and this part would be even, right? But then we see that from 1, 2, 3, 4, 5, 6, 7, 8, 9, we have 5 odd and 4 even, right? And so these red numbers must be odd, and our number in the center, it must also be an odd number, right? So first of all, 6 and 8 can't be possible. And now we take a look at our last condition. The numbers in the four corners add up to 18, right? And so for from our 5 odd numbers, 1, 3, 5, 7, 9, 4 of them must so 4 of them must add up to 18, right? And if we take the whole sum of 1, 3, 5, 7, and 9, then this is 18 plus 7, because 1, 3, 5, and 8, they make 18. No, sorry, 1, 3, 5, and 9, they make 18, and we have 7 left over. And so since the 4 on the corners will add up to 18, and this will be the only odd number left, then it will have to be 7. So this will be 7. The answer is C. Number 16, the sum of an infinite geometric series is a positive number s, and the second term in the series is 1. What is the smallest possible value of s? Okay, so the sum of an infinite geometric series, it's a over 1 minus r. If we start with a and multiply by r each time, right? And since the second term in the series is 1, that means ar equals 1, right? And so a equals 1 over r. And if we plug 1 over r into right here, then that gives us 1 over r over 1 minus r, right? And if we calculate this, then this would equal 1 over r times 1 minus r. And what is the smallest possible value of s? Okay, so we want the smallest possible value of 1 over r times 1 minus r. So we want the largest possible value of r times 1 minus r, right? And since this is, no, actually, let's make this negative 1 over r times, no, negative r squared minus 1, right? And so since we have a negative, but we want to make the whole thing as small as possible, we have to make this as large as possible, and to make this as large as possible, we need to make r squared negative r, sorry, that should be r squared minus r. We need to make this as small as possible, right? And so the minimum of r squared minus r, and if we draw a coordinate plane right here, then let's say this is the r-axis, and r squared minus r would go like this, and this would be 1, right? And so the smallest possible value occurs when r is at the midpoint, r is 1/2, and when r is 1/2, then the minimum point would be 1/4 minus 1/2, so that would be minus 1/4, right? And so the minimum possible value of r squared minus r, this is minus 1/4. And so this minus 1 over minus r squared so minus 1 over r squared minus r, this is minus 1 over minus 1/4, so these two cancel, it's plus, and so this is 4. So the answer is E. Number 17, all the numbers 2, 3, 4, 5, 6, 7 are assigned to the 6 faces of a cube, one number to each face. For each of the 8 vertices of a cube, a product of 3 numbers is computed when the 3 numbers are the numbers assigned to the 3 faces that include that vertex. What is the greatest possible value of the sum of these 8 products? Okay, so let's fold out this cube and make something like this, right? And so this is what a cube looks like. This is what a cube looks like when it's folded out. And so we need the greatest possible value of the sum of the faces. Like, so these 3 faces share this vertex, so the multiple of those will be computed, and these 3 because of this, and these 3 because of this, and so on, right? And so we need 7, and we need the 4 other largest numbers to be surrounding it, right? And so we need 6 and 5 right next to each other, because those 3 will make the biggest combination, and we need 4 here too, right? And we need 3 here, and that will naturally leave 2 here, right? And so now if we kind of look at 7 and 2 as the bottom and top faces, then we get that the 8 products will be 7 times, sorry, those 8 products will be 7 times 6 times 4, plus 7 times 5 times 6, plus 7 times 3 times 5, plus 7 times 3 times 4, plus 2 times 6 times 4, plus 2 times 5 times 6, plus 2 times 3 times 5, plus 2 times 3 times 4, right? And so now if we just add all of these together and take out 7 plus 2, which is 9, so that will be 9 times 6 times 4, plus 5 times 6, plus 3 times 5, plus 3 times 4. And so this equals 9 times 24 plus 30 plus 15 plus 12. This equals 9 times 54 plus 7 plus 27. And that equals 81. 9 times 81. And this is 9 to the cube, 9 cubed, which equals 729. So the answer is 729, it's D. Number 18. In how many ways can 345 can be written as the sum of an increasing sequence of 2 or more consecutive positive integers? Okay, so we can first divide 3, no, actually, since 345 is an odd number, we can write it first as the sum of 2 numbers. And those will be 344 divided by 4 equals 177, so it's 177 plus 178, right? And so we have it can be written as 2 numbers. And now let's try to divide 345. 345 is divided into 15, and if we divide 15, then that gives us 23, and 15 is 3 times 5, so so the factors of 345 will include 3, 5, and 23, right? And so we have the so our factors could be 2 because it can be written as two numbers, and 3 because it can be written as 3 numbers, 5, and the next would be 2 times 3, which is 6, and the next would be 2 times 5, which is 10, and the next is going to be 3 times 5, 15, and the next is going to be 23, and the next will be 30, right? But then in here they have to be consecutive positive integers, right? And so until 15, 345 is 15 times 23s, and since 23 is bigger than 15, it will obviously be all positive, right? All positive up until here, right? And for 23 and 30 we have to check, right? And so since if we have 23 numbers and the middle number is 15, right? Because 15 should be in the middle, right? And so then the lowest will be 15 minus 23 minus 1 over 2, which is 15 minus 11, which is 4, right? And so 23 is also okay. But if we have 30 numbers, then the middle would be, yes. But if we have 30 numbers, then we would have the first have the middle will be h, right? And so that would not be all positive, and so 30 can't go, and so we have 2, 3, 5, 6, 10, 15, and 23. That's 7. The answer is E. Number 19, rectangle ABCD has AB equals 5 and BC equals 4. Point E lies on AB so that EB equals 1. So that EB equals 1, and since BC equals 4 and AB equals 5, so AE will be 4. And point G lies on BC so that CG is 1. Okay, so this is 1, and since the whole thing is 4, BG will be 3. Segments AG and AC intersect EF at QMP respectively. What is the value of PQ over EF? Right, okay, so first of all, what we have to do is we need to draw some more lines, right? And so let's try to extend the line from Q to G like that, and extend the line from F, right? So up to right there, and this will be our triangle. And now let's kind of name this point. A, B, C, D, E, F, G are taken, and so let's say this is H, right? And so first of all, what we can see is we can compute the value of DF and FC, right? Because DF equals 2, so this is 2, and FC should equal 3, because the whole thing is 5. And now, because we can see that ABG and CHG, those are similar, right? And so, yes, and the ratio of the length is 3 to 1. And so the ratio of AB to CH should also be 3 to 1. And so we can figure out what CH length is. And so CH, this is 4 plus 1, which is 5. 5 times 1 over 3 equals 5 over 3. 5 over 3, right? And so CH is 5 over 3. Right? And now we need to find PQ and EF, right? And so first of all, AEQ and HFQ, those are similar triangles, right? And the ratio of their length is 4 to 3 plus 5 over 3, right? And so that would give us the ratio of EQ to QF, right? And so if we have EQ and PQ and PF, right, then EQ to PQ, then the ratio of EQ to PQ plus PF, that will be 4 to 3 plus 5 over 3, which is 14 over 3, and 9 plus 5 is 14, yes, so that's right. And 4 would be 12 over 13, no, 12 over 3, and so 12 to 14, that's 6 to 7. So this would be 6 to 7. And next, what we want to see is that triangle AEP and CFP, they are also similar, and this time their side length ratio is 4 to 3. So EP to PF, the ratio is 4 to 3, and so this time EQ plus PQ, so this ratio to this ratio, this is 4 to 3, right? And so since these are the ratios, to get the ratio for EQ, PQ, and PF, what we need to do is we have to multiply 7 to each of these, because 7 is 4 plus 3, and we have to multiply 13 to each of these because 13 is 6 plus 7, right? And so if we do that, EQ, PQ, and PF will be EQ equals 6 times 7, which is 42, PF equals 3 times 13, which is 39, right? And PQ equals 4 times 13 minus 6 times 7, which is 52 minus 42, which is 10, right? And so the PQ over EF, PQ's ratio is 10, right? So it's 10 over EF is all of these combined, 42 plus 10 plus 39. And so that will be 91, right? And so that will be 91. So it's 10 over 91, which is D. Number 20, a dilation of the plane that is a size transformation with a positive scale factor, since the circle of radius 2 centered at a 2, 2, to the circle of radius 3 centered at a prime 5, 6. What distance does the origin 0, 0 move under this transformation? Okay, so first we can set our coordinate planes. So this will be our first coordinate plane, and our other coordinate, our x-axis, this will be our x-axis. And so now the first circle was radius 2 and the second circle was radius 3, right? And so if we graph that, so those would be our and so those would be our circles, right? And it asks us what distance would the origin move, right? And so first we have to figure out the relationship between O and A, right? And so if we look, O is where the two tangent lines from A meet, right? And so it's where the two horizontal and vertical tangent lines from A meet, and that's O. And so if we do the same for the moved one, the two tangent lines for A prime, that's this one and this one, right? Actually, let's do that in orange. It's this line and it's this line right under here, right? And so the new O, that would be at this intersection point, that's at this point here. And so this is the new O. What distance does the origin move under this transformation? So that will be the distance from O to right here. So that's a distance of, if we do the Pythagorean theorem, root 2 squared plus 3 squared equals root 13. So the answer is C. Number 21, what is the area of the region enclosed by the graph of this equation? Okay, so first we first we notice that this is same when x is flipped. So it's the same when we flip it by the y-axis, and it's also the same when we flip it by the x-axis. So that's when y is flipped. So that's when the y value is flipped. So we flip it by the x-axis, right? And so so if we have something like that, and then we will have something symmetric and something symmetric like that, right? But that's not what we have. And let's see what we have. If x and y are both positive, right? Then x squared plus y squared equals x plus y. And so that will give us x squared minus x plus y squared minus x, no, y squared minus y equals 0. So x minus half squared plus y minus half squared equals 1/4 plus, no, that's 1/2 plus 1/2. So this, yes, so that is 1/4 plus 1/4, it's 1/2, right? And 1/2 is the square of 1 over root 2, right? And so if we draw this in a coordinate plane, it will look something like this. So this will be the graph for this equation when x and y is greater than or equal to 0, right? But then we said that it's the same when x is flipped and the same when y is flipped, right? And so and so what that means is we will have the same semicircle thing over here and over here and over here, right? And so if we draw that a little better, and so this is what it will look like. And if we put in some extra lines, right, that connect to these values, then that would give us the realization that here we are looking at 4 semicircles, right, we are looking at four semicircles, and this is because my drawing is bad, but this is actually a square, right? And so this is the radius, and as we saw, the radius is 1 over root 2, right? And so this much is 1 over root 2, and so yes, and this is x minus 1/2, y minus 1/2, so this is 1/2 and 1/2, and so that means this much is 1 and this much is 1, right? And so the area of the the area of this blue region, this will be equal to 1 times 1, so 1 times 1, that will be 2 of these times 2, right? And so times 2 will be 2 of these, so that will be the whole thing, and so this equals 2, right? And now for the 4 semicircles, like this, like this, like this, and like this, right? And so they would, and so since they have a radius of 1 over root 2, that's 2 full circles, right? So this would equal 2 full circles, so pi r squared, so 1 over root 2 squared, and so this is 2 times pi times 1/2, right? So this is pi, and so the area, so the full area of the region is 2 and pi together, that's 2 plus pi. The answer is B. Number 22, a set of teams held a round-robin tournament in which every team played every other team exactly once. Every team won 10 games and lost 10 games. There were no ties. How many sets of 3 teams, A, B, C, were there in which A beat B, B beat B, and B beat C, and C beat A? Okay, so first of all, since every team won 10 games and lost 10 games, that means every team played 20 games, right? So since every team played 20 games, there were 21 teams in total, right? And for every team, there was 10 which it won against, and 10 which it lost against, right? And so the scenario that we want is we want 3 teams A, B, C, where A beat B, B beat C, and C beat A. A beat B, B beat C, B beat C, and C beat A, right? But then if you think about it, the only other solution, so the only other possible solution, is if one team won both of the other teams, right? And so we have A won B and C, or A won B and was lost by C, right? Because if even one of these arrows turned away, then that would make it the same as this, right? And so and so what we have to calculate is calculate the total number of possible 3 team combinations minus this one, A wins both B and C, right? And so first of all, the total number of possible 3 team combinations, that would just be 21 teams, so 21 choose 3. 21C3, this is 1330. So we have 1330 there. And now we only need to know how many teams are like this, right? So first of all, we choose one team out of the 21 to be the team that wins. So that's 20, so that's 21. 21 choose 1, right? And then we want, yes, and then so this is our A, right? And so we need to pick 2 teams from the win, and so we need to pick 2 teams from the win kind of category, right? And so it's 10 choose 2, right? And so that will be the total possible numbers of 3 team combinations that are like this. So that will be 21 times 10 choose 2 is 10 times 9 divided by 2, so it's 45, right? And that is, what is it, 945, right? And so what we needed to do is this, which is 1330, minus this, which is 945. So we need 1330 minus 945, and that equals 385, right? And so the answer is 385. It's A. Number 23, in regular hexagon A, B, C, D, E, F, points W, X, Y, and Z are chosen on sides B, C, C, D, E, F, and F, A respectively. So lines A, B, Z, W, Y, X, and E, D are parallel and equally spaced. What is the ratio of the area of hexagon W, C, X, Y, F, Z to the area of hexagon A, B, C, D, E, F? Right, okay, so let's try to draw a diagram of this. So this would be what that looks like. And so WCXYFC, so that's this region right over here, and we need to calculate this ratio with this whole ratio, right? And so it would be great if we could just like divide everything into like these small triangles and just count them all to do the math. And so first of all, what we need to see is that ZF to AF, the ratio is 1 to 3. And that's because AB, ZW, YX, and ED, so these are equally spaced, right? And so that means that if this is 2, then this is also 2 and this is also 2. And so if we have a line right here, then this would be 2 also, and this would be 1. And so since this and this are similar triangles, this would be 2 and this would be 1, right? And so by that exact same logic, FY to FE is 1 to 3, 1 to 3, and 1 to 3 also. And so now if we just draw these small triangles, then this is what we get. This is the result, right? And so what we need to do now is we just have to get the number of triangles inside here and compare that to the number of triangles and everything, right? And so inside we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 inside, and outside we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So we have 22 plus 16 on both sides, and so this is 22 over 54, and so this is 11 over 27. So the answer is C. Problem number 24. How many 4-digit integers a, b, c, d with a is not 0 have the probability that the three 2-digit integers a, b is less than b, c is less than c, d form an increasing arithmetic sequence? So one such number is 4, 6, 9, 2, where a equals 4, b equals 6, c equals 9, and d equals 2. Okay, so for a, b, b, c, and c, d, then we have 10a plus b, and 10b plus c, and 10c plus d, right? And going to each of these, our differences are an increasing so our differences are an increasing arithmetic sequence, right? And so the difference between these two values will equal the difference between these two values. And so if we do that, that will be these two values difference is 10b plus c minus 10a plus b, and that would equal these two values differences, which is 10c plus d minus 10b plus c, right? And so if we so if we put all the 10s to one side, then that will give us 10b minus 10a and minus 10c plus 10b would equal, and then all the ones on here side, so it's d minus c plus b, right? And so 10 times 2b minus a minus c will equal negative 2c plus b plus d, right? And so since a, b, and c and d, they are all integers, that means this is an integer and this is an integer. But then that means this is a multiple of 10, right? And so minus 2c plus b plus d is a multiple of 10, right? But then for that to be true, then the maximum value can be 18, right? Because that's when b is 9, d is 9, and c is 0, right? So since the maximum value is 18, so this can only be 10 or 0, right? And so 2b minus a minus c equals either either 1 or 0, right? Because that way this will be 10 or 0, right? And so now all we do is list our probabilities based on whether 2b minus a minus c is 0 or whether it's 1, right? And so if 2b minus a minus c is 0, then that means 2b equals a plus c, right? And so that just means a, b, c, d itself will be an arithmetic sequence, right? And so those values will give us numbers that are 1 2 3 4, or what else can there be? 2 3 4 5 3 4 5 6 4 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9, or it could be 1, 3, 5, 7, 2, 4, 6, 8, and 3, 5, 7, 9. 3, 5, 7, 9, right? And so how many values are those? We have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So we have 9 here. And as for 2b minus a minus c equals 1 here, 2b equals a plus c plus 1, right? And so c can be 9 or 8 or 7, right? 9 or 8 or 7. And so when c is 9, it's 2, 5, 9, 3, or 4, 6, 9, 2, or 6, 7, 9, 1, or 8, 8, 9, 0, right? And when c is 8, it can be 1, 4, 8, 2, 3, 5, 8, 1, or 5, 6, 8, 0. And when c is 7, it can be 2, 4, 7, 0, and that's all, right? And so that gives us 4, 7, 1. So that's 8 values. So our total is 9 values plus 8 values, which is 17. The answer is D. Number 25, let fx equal the summation of k equals 2 to 10, the floor of kx minus k floor x, where the floor of r denotes the greatest integer less than or equal to r. How many distinct values does fx assume for x is greater than or equal to 0? Okay, so first thing, we will check what fx plus 1 is, right? Fx plus 1, and so if we do that, that's the summation k equals 2 to 10, and then kx plus 1 floor minus k floor of x plus 1, right? And so this and so if we just take the value inside the summation, this will equal summation kx plus summation k1, right, minus k summation x minus k summation 1. And so this will be summation k of x, no, sorry, that will be the floor of kx, and then these two cancel, so minus k floor of x. But then if you see, this is the exact same as this, right? And so fx plus 1, this actually is equal to fx. And so this means that and so because of this, all the distinct values for fx when x is greater than is equal to 0 is equal to the distinct values for f of x when x is within this range. So when x is greater than or equal to 0 and less than 1, right? Because, right? One more thing is that if x is greater than or equal to 0 and less than 1, that means the floor of x equals 0, right? And so the floor of x, this is 0. So k floor x is going to be equal to be 0, right? And so our fx is summation k equals 2 to 10, and it's just the floor of kx, right? And since we want the distinct values for fx, that means kx must be an integer, right? And so since k can be all the way from 2 to 10, then that means that the values for so number of values of fx, equals all fractions between 0 and 1 with denominators being 2 to 10, right? And so that will give us first of all we have 1 over 2, and then we have and 9 over 10, right? And so let's count these numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we have 15, 20, and we have 25, and we have 30, and we have one more, so we have 31 values, right? But then 31 is not the answer, because we have to add one more, and that's when that's when x equals 0, right? Because when x is 0, there is a 0 value of fx, which is a new number, right? And so 31 plus 1, that will be equal to 32, right? So the answer is 32. It's A. So that was it for AMC 10B from the year 2016, and thank you for watching.